Now that we understand the interaction between the base workspace and the function instance workspace when a function is called, let's investigate when a function calls another function. For this, we'll consider two very simple functions. Times2 returns an output argument which is twice the input argument, and T2P5 calls times2 and then adds 5 to that to return its output argument. We'd like to investigate if we define a variable in the base workspace and then call T2P5 on that variable, what is the sequence of events that occurs? Define the variable d that appears in the base workspace. Then we call T2P5, which creates a function instance for T2P5. The variable d is passed as the input argument and becomes the variable a in the function instance workspace for T2P5. The next line of T2P5 calls times2. The variable a in the T2P5 workspace is passed as an input argument and becomes the variable a in the function instance workspace for the times2 function. The next line of code in the times2 function executes, defining a variable b whose value is 6. This value is in the times2 function instance workspace, and that's the last line of code for the times2 function. The times2 function will exit, returning its output to the suspended T2P5 function. This causes temp to take on the value of 6, and control is now returned to the T2P5 function. The next line of code adds 5 to that variable, resulting in a new variable in the function instance workspace, b, whose value is 11. The T2P5 function exits, returning this value 11 as the output argument. C takes on that value, and no more functions are executing. Let's run this example in Matlab and have a few more printouts to exactly see what's going on. Here's the T2P5 function. The main code was to call times2 and then add 5 to that result, return that as the output argument. What I've done is I've added a line that declares that we're in T2P5 and then runs dbstack, and finally a line at the end that shows that we're leaving T2P5. For times2, the main line of code is to take the input argument and multiply times 2 to produce the output argument. Again, I've added a display which declares that we're in times2 and runs dbstack, and finally another display leaving times2. Let's call T2P5 from the command line and see what happens. In the slides, we declare d equals 3 and then c as a call to T2P5. This will execute very quickly, and then we'll analyze exactly what is displayed. The first thing that is displayed is that we're in T2P5, which makes sense. That's the function that was called. dbstack lists that we're at line 3 in T2P5. Let's check that in the editor. Line 2 generated the display, and line 3 is the call to dbstack, which prints out that execution is at line 3 in T2P5. The next line, line 4, makes a call to times2. Let's look at times2. In times2, line 2 prints out that the execution is in times2. dbstack shows that execution is at line 3 in times2, while TP25 is suspended at line 4. Let's go back to T2P5 and verify. It is indeed in line 4, waiting for times2 to finish. Back in times2, line 4 executes, resulting in the new variable b, and then line 5 displays that we're leaving times2. Control returns to T2P5. The variable temp is the output argument from the call to times2. 5 is added to it, resulting in the variable b. Finally, leaving T2P5 is displayed in the command window as shown. At this point, T2P5 exits and control is returned to the command window with the variable c being the output argument from T2P5. Let's check that C is indeed 11.